35 years ago, the fire department didn't respond to a fraction of what it responds to now. The expectations on the fire department were much less than they are now. General automation in society, so sprinkler systems and automatic fire alarms, have changed the job responsibilities of a firefighter tremendously, have put a bigger demand on the fire service. So the stuff that we carry now to respond to those sort of emergencies has changed things dramatically. And they're all consumable items that need to be tracked. When I started in 1978 in the fire department, no axe had an expiration date on it. Either it worked or it didn't. And now that's all kind of changed. And so the need for technology has really ramped up. This is an RFID inventory tag. So it's a radio frequency tag, which means it can be scanned from a few meters away. The iPod that's attached to this reader has an app built into it. And this gives us the ability to come to a compartment like this, quickly scan the tags that are in there, and produce a very quick inventory of what we need in the compartment, or what's potentially missing, or has been damaged and has been turned in for repair. It very quickly gives the firefighters the chance to scan the truck and know that the vehicle is ready for them to respond to a call the minute they come into work. We have a requirement that we have a certain amount of equipment before that truck can be in service, before it's ready to respond to anything. And using this technology, we can guarantee that readiness from shift to shift. So we found out that we'd have a tag, it'd be on there for a few days, and we'd finally respond to some sort of event, and we got all our stuff back, but we didn't get any tags back. They had been knocked off either from heat causing the adhesives to release, friction of something striking the object and peeling it from the surface, those kind of problems. Because the fire service is a tough place to be a little tag, the adhesive strips on the back don't hold up as well as they would in another application. So we're using 3D printing to create a better area to embed the tags so they're more durable in our environment. Counting hose couplings, all the consumable items in an EMS bag, you could easily go over 400 or 500 items. We carry a wide variety of stuff that ranges from removing smoke from a building to having the tools to rescue people from automobile accidents. We also do water rescue. So there's a wide variety of stuff that has to be tracked every single day. And having one tag that could go onto a piece of wood or onto a generator or a light just isn't really possible. So 3D printing gives us the ability to create that bridge between the tag itself and the object we're trying to track. So since the adhesives don't hold up in the long term for us, we're looking for ways for mechanically fastening our tags to a device that was really never intended to have one on it. All of our items have been well designed, they're well engineered, and so for us just to take something and stick it on the side of it isn't always a great option. So what we've done is disassembled some of these things, and we're replicating one of their parts on the 3D printer and building a pocket in there we can stuff a tag in so we can inventory stuff. Makes the item trackable for us easily, but it doesn't change the function of the item for someone that's never seen the tags before. That's really what we're after, is we're looking for a way to mechanically fasten those tags without altering the item too much, and being able to hide the tag to where it doesn't influence the function and kind of keep it out of the heat, keep it out of the weather, all those sort of things. Everybody has the same issues. They're having the same increased workload and the same burdens put on them, and everybody's kind of looking for an answer for it. And so that's what we're doing here, is trying to provide the framework for at least one way to solve these kind of problems going forward.